Hello. I had some students asking me about factoring and having trouble with 4344, where it asks us to run through different methods of factoring. So I thought I would post a couple of videos that looked at 3 different methods of factoring. I can post some more videos that talk about the other method that we'll be employing as we work through the Chapter 4 items of review for factoring as well later this week. So the first method we talk about when we're factoring is greatest common factor. And this is our first go-to method of factoring. And so when we're looking for a greatest common factor, we are looking for the highest factor that all terms in a polynomial share. And we want to remember that as we factor, we're not going to drop that factor. And just as a quick reminder, when we're talking about factors, when we learned about basic multiplication, so something like 2 times 7, we combined these numbers through multiplication to get an output value of 14. And this value that we got, we called it our product. And the numbers that we multiplied or combined to create that 14, those are what we called our factors. And so when we're looking to factor our polynomials, we're looking to rewrite it in terms of a multiplication problem rather than its already simplified form. So we're trying to unsimplify this and write it in terms of multiplication, which is another reason we're not going to be dropping our factors. So I have a few examples written out. Here I gave you 6x squared plus 2x minus 12. When I look at these values, or these 3 different terms, they don't all have a common variable. So this has an x squared, this has an x, but this one does not have any variable, which means there's not going to be a variable as part of my greatest common factor. And when I look at the numbers, 6, 2, and 12, the largest common integer factor they have is going to be 2. And that's the most that all 3 can give evenly. Even though 6 and 12 both divide by 6, this 2 is not divisible by 6 because 2 divided by 6 gives us a partial value and not an integer value. So we can only use 2 as our GCF. And so I just like to write myself a note so that I don't forget what my greatest common factor is supposed to be as I'm working with this problem. So for this GCF, we're going to go through and just do this series of monomial divisions to factor out that 2 from every one of those terms. And when we do that, again, our goal is not to get rid of this factor, it's just to bring it forward as a standalone item in this factorization. So we're going to have 2, it's going to be multiplied with, and you can either put that dot, or we sometimes just put the parentheses to imply the multiplication has to occur. And we're going to write down what happens when we do this division and what's left over. So 6x squared divided by 2 will leave me with 3x squared. The 2x divided by 2 will leave me with an x. And the negative 12 divided by 2 will leave me with negative 6. So I get this polynomial 2 times the quantity 3x squared plus x minus 6. And so this is the factored form of this original polynomial. And if we're not entirely certain that we factored correctly, we can always check our work by just redistributing and making sure that when we do, this operation results in the original polynomial we started with. So for this example, if we decided to check, 2 times 3x squared would give us 6x squared, 2 times x would give us 2x, and 2 times negative 6 would give us this negative 12, and that is in fact the original polynomial that we started with. And like I said, we don't have to do that. I just want to remind us that we always have the option to check. But our goal here was to factor. This is the factorization of this polynomial by looking for the greatest common factor. Here on this one, we have 4x to the 4th minus 18x to the 3rd plus 12x squared. For the coefficients, all of these coefficients are divisible by, again, 2. 4 and 12 are both divisible by a higher value of 4, but the 18 is not. 18 and 12 are divisible by 6, but the 4 is not. So again, I can only take out a 2. 2 is not always our only GCF, that just happens to be what we have for both of these examples. So for my GCF, I'm going to have 2. On this set of terms, x to the 4th, x to the 3rd, x to the 2nd power, I actually do have variables in each. When I have the same variable with different powers or different exponents showing up in my polynomial, the lowest degree that I have that's going to be part of my greatest common factor. So between x to the fourth, x to the third, and x squared is our lowest degree exponent of the variable x, so this will be part of the GCF. So our GCF is going to be 2x squared here. And again, we're going to write that down so that we don't drop it. We're going to start our set of parentheses, and to figure out what goes inside those parentheses, we're doing a series of little monomial divisions to see what's left when we do that factoring out of the 2x squared from each of these terms individually. So 4x to the fourth divided by 2x squared becomes 2x squared. We have the subtraction. 18x to the third divided by 2x squared will become 9x. And the 12x squared divided by 2x squared, the x's will cancel completely and leave me only with the coefficient or constant value of 6. So this would be my resulting factorization. And if all they're asking me to do is factor out the greatest common factor, this is as far as they're asking me to go right now. If our leading term in this situation, the negative 3x to the fourth, is negative, along with whatever else we're taking out for our GCF, we also recommend taking out the negative because as we progress through factoring, we don't want our leading coefficient to be negative because that causes problems for us. So here, for our GCF, I'm going to want it to be negative because the leading coefficient is negative. When I look at the 3, the 6, the 15, all of these are divisible by at most 3, so that's going to be a negative 3. I have an x to the fourth, an x squared, and an x. This is the lowest exponential quantity of x that we see in this problem, so we can only take out at most this x. So negative 3x will be our greatest common factor here. So again, I'm going to write that so that I don't forget that this is my greatest common factor, and I'm pulling it forward as a factor. I'm not canceling it out. And then I want to see what happens to these terms individually when I do that factoring out of that factor, negative 3x. So here, negative 3x to the fourth over negative 3x. The negative 3's will cancel. X to the fourth divided by x will leave me with x to the third. So in parentheses, I'll write that. The negative 6x squared divided by the negative 3x, because of this double negative, will become positive, so we can go ahead and write plus here. 6 and 3 should give me 2. X squared and x will just drop it down to x, so plus, 2, not 3x. And then here, positive 15 divided by the negative 3, that's going to give me a negative result of negative 5. The x's are going to cancel. So this is going to be my factorization. Negative 3x times the quantity x cubed plus 2x minus 5. And again, for now, that's as far as they want us to go. One last one, it's a little oddball one. So here I've got this 8x times x minus 3 plus 2 times x minus 3. Even though it doesn't look like it, this whole part here gets to act like one term, and this whole part here gets to act like one term. And so when I look at them, the 8 and the 2 are both divisible by 2. Also, both of them have this x minus 3 factor sitting inside of them. So I can take that for my GCF as well. So on this particular problem, our GCF is going to look a little strange. It's going to be 2, and it's also going to be this quantity x minus 3, because these are both factors that both of these terms share. So I'm going to use those as factors. I'm going to divide that quantity and the 2 out of each of those terms. And because those quantities are in parentheses, we can just cancel them exactly with each other. The 8x and the 2, when I do that division, I should get a 4x. And here, the x over minus 3's cancel, the 2's also cancel. We can't just leave a blank space here. Even though these are canceling, technically we are getting left with a term of 1 here. So I would have a 1 there as its placeholder. So I'm going to have 2 times x minus 3 times 4x plus 1. And that's the complete factorization of this kind of messy polynomial they've given me over here. And the reason I do this is because this will help us when we have to do factoring by grouping. I hope that helped. If you need any other examples, please let me know. I'd be happy to post more. Thank you.